solve a system of linear equations by graphing. So we're going to look at two equations at the same time. When we look for two equations at the same time on a graph, there are three possible things that can happen. The first thing that could happen is that the two lines intersect. If the two lines intersect, this point of intersection is the solution, because if I plugged it into both equations, it would work. The next thing that could happen is the two lines could be parallel. If the two lines are parallel, then they don't intersect. The third option is that the two lines be on top of each other. If the two lines are on top of each other, then they intersect at infinitely many places. Therefore, there are infinitely many points that can plug into both equations and get something that is true. So here is a graph of each of the three scenarios. The first scenario has parallel lines. Parallel lines don't intersect. Therefore, there is no solution to this system. Remember that a solution to a system is the point where the two lines intersect. Because there's no intersection point, there's no solution. The next scenario is when I have two lines that are on top of each other. I realize that's a little bit hard to see, but if there's two lines that are on top of each other, then they intersect in infinitely many places. Therefore, there are infinitely many solutions. The third option is that the two lines just intersect at one point. So if they intersect at one point, there's only one solution. Now let's try some examples. Here I'm trying to find the solution to the system of equations by graphing these two lines. So we're going to have to refresh our memory a little bit about how to graph a line from Algebra 1. If you remember, a general form of a line is y equals mx plus b. Hopefully you're familiar with this from Algebra 1. The m represents the slope, and the b represents the y-intercept. Slope is the pitch of the line, or how slanted it is. The y-intercept is where the line intersects the y-axis. So, for this first equation that we're dealing with, the number in front of the x is 1. Therefore, our slope is 1. The number added or subtracted on here is -3. Therefore, our y-intercept is -3. Now let's try to graph the line. In order to graph a linear equation, it's very simple. You just go to the y-intercept. In this case, it's -3. And you start there. Then you use the slope pattern to get to the next point. Remember that slope is rise over run. So I go up 1, over 1, up 1, over 1, and so on. I'm going to continue this pattern until I fill up the entire graph. Here, I have graphed my first line. Now let's move on to the next equation. Here we have things written in a little bit of a different order, but it's really the same idea. So y equals 5 minus 3x. It's really the same as y equals -3x plus 5, if that helps you identify the slope and the y-intercept more easily. The slope is -3, and the y-intercept is 5. So to graph this line, I go to my y-intercept first. That's 1, 2, 5. And then I follow my slope pattern. -3 is a fraction, is -3 over 1. So I go down 3 over 1, down 3 over 1, and so on until I fill up the entire graph. I want to make sure I use the entire graph so that I'm sure to find the point of intersection. So if I draw my line here, I can see that these two lines intersect here. Therefore, this is the solution point. If you remember how to label points, this is the point 2, negative 1. So 2, negative 1 is my solution. To verify my answer, I'm going to check that in both equations by plugging it in. For example, if I take this first equation and plug in the point 2, negative 1, I get negative 1 equals 2 minus 3. I've received this by plugging the negative 1 in for y and by plugging the 2 in for x. Now I just have to verify whether or not the statement is true. Because negative 1 does equal 2 minus 3, the first equation checks. Now let's try the next one. We're going to do the same thing. I'm going to plug negative 1 in for the y. Then I'm going to plug 2 in for x. So I'm trying to verify that negative 1 does equal 5 minus 6, which is true. So this point did work for both equations. That's why it's the solution. These two lines only intersected in the one spot, so there's one solution. Let's try just one more example. So here I have two equations. The reason that this example is a little bit more difficult is because these two equations are not solved for y. They're not of the form y equals mx plus b. In order to graph them, it's probably a good idea to translate them into that form. So let's take this equation first. X plus y equals 5. Solve for y, that's how you get it into the form. You get the y by itself. I'm going to have to subtract x from both sides. After I do that, I get y equals negative x plus 5. Now let's identify our slope and our y-intercept. My slope here is negative 1. My y-intercept is 5. So to graph this line, I'm first going to begin with my y-intercept of 5. Then, negative 1 as a fraction is negative 1 over 1. So I'm going to go down 1 and over 1, over to the right one to get to the next point. I'm going to continue this pattern all the way. And in the other direction. And draw my line. Now let's try to do that same idea with the next equation. There's just one additional step. So I'm going to take this equation and try to solve it for y. If I want to solve it for y, I need to get the y alone, which means that I first need to get rid of the x. So I'm going to subtract x from both sides. Hopefully you're familiar with solving from algebra 1. Then negative 5y equals negative x minus 7. Now, in order to get this y alone, I'm going to have to divide by negative 5. If I divide each quantity by negative 5, I do end up with fractions. So here I'm going to have y equals negative divided by a negative is a positive, so it's just going to be x over 5. Negative divided by a negative again is a positive, which will be plus 7/5. So now we're going to identify our slope and our y-intercept. Here our slope is 1/5. Because there's really a 1 in front of this x. And our y-intercept is 7/5, which is not very convenient. 7/5 is 1 2/5, so that allows me to know approximately where I should start my graph. So about here. A little bit more than 1. Then I'm going to go up 1 and over 5. Up 1, 1, 2, 3, 4, 5. Up 1 and over 1, 2, 3, 4, 5. And so on. And draw my line. Here's another example where the lines intersect at only one point. This point would be the solution. It's a little bit hard to pinpoint exactly where that point is because we dealt with fractions in the problem. So that point looks like it's about 2.5. 2.5. This is an approximate solution. Now let's try this example. So So here's another example where I have two equations that are not solved for y. I have to get the y alone before I begin. So let's start with the first one. Here I have 3x plus 4y equals 8. I want to try to get the y alone so that I can obtain the form y equals 10x plus 8. So the first thing I'm going to do is subtract 3x from both sides. I'm going to get 4y equals negative 3x plus 8. My next step to get the y alone would be to divide by 4. Divide each quantity by 4. I end up with y equals negative 3/4 x plus 2. Now I'm going to identify my slope and my y-intercept. My slope here is the number in front of the x, or negative 3/4. My y-intercept is 2. So to graph the line, I start at the y-intercept, and then I follow the slope pattern to get to the next point. Rise over run, so I go down 3 and over 4. Down 3 and over 4. I'm going to also do some in the other direction. Up 3 and to the left 4. Up 3 and to the left 4. And I have a line. Now let's do the same thing with the second equation. Here, to get the y alone, first I'm going to add 12 to both sides. I end up with 4y equals negative 3x plus 12. And I'm going to divide each piece by 4 and get y equals negative 3/4 x plus 3. So here, my slope is negative 3/4, and my y-intercept is 3. So I'm going to graph this line by first going to my B and following the slope pattern. Go down 3 and over 4. Down 3 and over 4. And same in the other direction. Now here we have a different scenario. Here the lines are parallel, therefore they don't intersect. Hopefully at this point you realize that this means that if there's no intersection point, there is no solution. Thank you for listening, and please answer the questions on the page for credit for listening to this presentation. Thank you.